Tripartite Tuesday, the 1st of December, the very first of this last month of the year, okay? SWBA. Students will be able to classify triangles by sides and angles. Section 5.1. We are moving on to Chapter 5, okay? So Chapter 5, we're talking about triangles like crazy. Actually, the next few chapters we're talking about triangles like crazy. So this is kind of our introduction to triangles. So we're going to learn a lot about different classifications of triangles today, what they are, what the parts of triangles are, that kind of stuff, okay? So a triangle, our definition of it is a polygon with 3 sides, okay? A polygon just means a many-sided figure. So it's a polygon with 3 sides. And we can name the triangle shown to the right in a couple different ways. So one way you could do it is you could write out the word triangle, and you just name the 3 points of the triangle in literally any order you want. So we could do triangle ABC, for example. You could do triangle BCA, BAC. You can do any order you want, any of the 6 possible combinations you could do. Or, if you want to use symbols and be lazy, you could draw a mini triangle and do ABC for triangle ABC.
Who's going to use the first one?
I'm going to say you already know which one I'm going to use. Hence, I already used it on the board.
My triangle looks like a distance.
How many is it?
23 foot, 10 inches.
My goodness.
That's 3 Leo.
So like
That's 4
24
Leo.
feet.
You might want to write that down on the board, actually. I need to tell Hayden that. All right. So we can classify triangles in a couple different ways. The first way we're going to talk about classifying them is by their sides. Side. Like Psyduck? Okay.
What?
Psyduck, you know, from like Pokemon. No one knows. Okay, never mind.
I think
Nerd.
Sorry. This is I'm too old for you guys. This was like the OG Pokemon when I was growing up.
Charizard and Squirtle.
Oh.
I thought you were gonna say
Squirtle,
like
Squirtle.
I thought you were old enough
And
to
Jigglypuff.
I am old enough to like Yu-Gi-Oh, but Pokemon was before Yu-Gi-Oh.
Yeah, Jiggly.
Yeah, the OG Pokemon was before OG Yu-Gi-Oh.
I just know that Yu-Gi-Oh is I think.
3?
Or like selling.
Ow, please,
Yeah.
my blue.
It's been around like 25 years.
Pokemon cards are like selling for $10,000.
Some of them. Anyway, so we have a scalene triangle. A scalene triangle has no congruent sides.
No.
None of the sides are congruent. They're all different lengths.
Hey, remember?
This is an example of a scalene triangle where they are all different lengths. Isosceles, yes, it's a fun word to spell. Okay, isosceles. No, isosceles triangle has at least 2 congruent sides. Now we say at least 2 congruent sides, but we really, it really ends up just being 2. Okay, so it can have 3 congruent sides and still be considered isosceles, but you never call a triangle with 3 congruent sides isosceles. Okay, you just never will. Okay, it technically is, but we just have a more specific name for it, which is the equilateral triangle, which has 3 congruent sides. Now, back up a second to the isosceles triangle again. If you notice here, the 2 congruent sides marked by these red tick marks are called the legs. Okay, so there are 2 congruent sides, and we'll call them the legs. The other one, the non-congruent side, will be called the base. Regardless of whether the base is on the bottom or the side or what, it'll be called the base when it's the non-congruent side. Now, equilateral, if we kind of look at this first part, what's that kind of look like? Equal. Lateral means side. Okay, you might know in football, for example, a lateral pass is a pass to the side. Okay, or lateral jumps, you're jumping to the side. Okay, anytime you're talking about lateral, we're talking about sides. It's
Lateral, like you...
Yeah, in football, you technically have to go side and a little bit of the back to make it a legal play because you can't pass it forward. But technically, lateral just means side. So equilateral means equal sides. So all 3 sides of the triangle are congruent as marked. Questions on that? Danked open Liddy. We can also classify triangles by their angles. So we can classify by their sides, which we have 3 different types. We can classify their angles, which we have 4 different types. So we have the really good looking one, acute triangle. Okay, an acute triangle will have 3 acute angles. Now, a reminder, an acute angle is between what 2 measures?
1, 0, and 9.
Yeah, it's somewhere between 0 degrees and 90 degrees. Your angle measure is somewhere between 0 and 90 degrees. So x is between 0 and 90. It's greater than 0, but it's less than 90. It's somewhere in that range. So all three angles in this triangle, for it to be an acute triangle, are going to be acute angles. We have a right triangle, and it's not just because it's correct. It has one right angle. So one of the angles is a 90-degree angle. Now, when we have a right triangle, we also see legs. So we see legs in isosceles triangles. We also see legs in right triangles. In the right triangle, the legs are not necessarily congruent. Okay, the legs are not necessarily congruent. They're the two sides that are touching or adjacent to the right angle. Okay, the two sides touching or adjacent to the right angle. It's almost like they're holding up the right angle is what some people think of it as. And then the hypotenuse, which you've probably heard that name before, is the one that the right angle is pointing towards, if you think about it, or it's opposite the right angle, okay? Dominic, what are you doing with your eyebrows? Yes, it's weird, okay? Bless you must raise down after lest you forget. It won't be a triangle then. Okay? We have an obtuse triangle. An obtuse triangle will have one obtuse angle. And we can see here, this angle does look to be obtuse right up there. Now, what does an obtuse angle remind me? What range is that in?
Fat, obese.
Bigger than 90.
That's how I remember it.
And what is it less than?
180.
180. So an obtuse triangle will have one angle that is bigger than 90 and less than 180. So could I guess we'll get here in a second, excuse me. Now you guys probably know, how much do the angles of a triangle add up to?
180.
180, okay? So is it possible to where if one of the angles is a right angle, could another angle be a right angle or could another angle be obtuse?
No.
No, because if one of them is 90, take away 90 from 180, we're left with 90 degrees for the other two angles to add up to.
So one could be 89, one could be 1.
So one could be 89, one could be 1, but that's really like they couldn't get to 90, okay, or no above 90. And same thing with obtuse. If something's above 90, then the other two angles have to be acute.
Did you go away?
Okay. What?
What if a triangle is 181?
Then it won't be a triangle in Euclidean geometry.
What if
Yes.
No, I have an add-on to this. What if one of the angles is 179 degrees?
Then the other angles would have to be 0.5 and 0.5 or something similar.
Actually?
Yes. Yeah, they do.
Like this.
Huh. Get rigged.
Yeah.
Oh, Max just gets smoked.
Huh. Stupid
Yeah.
Iowa fan.
I said that you could have 0.5 in an angle. You're gonna have to question.
No, I mean, he's correct, okay? Anyway, equiangular triangle. Equilateral was the sides being equal. What do we think equiangular is going to be?
All sides congruent. That's 3.
Angles are equal. Angles have equal measure, okay? Equal. Angular, angle. Equal angles. Okay, so it has 3 congruent angles. Now, if a triangle adds up to 180 degrees, what would each angle be then?
60.
Yeah, each angle would be 60 degrees there. So this is really a more specific type of an acute triangle. Very good, Aiden. So this is an acute triangle, but it's more specific. Okay? Yes, Max.
So, so whatever we have like an equal angle, whatever triangle and an equilateral triangle, you can classify them as well. You can always classify one as the other, correct?
We'll get there in a bit, but yeah. Okay? Any other questions on these classifications by angles or by sides? Okay? I want you guys to try classifying these 4 triangles by both sides and their angles. So by sides, scalene, isosceles, equilateral. And then by their angles, acute, right, obtuse, and equiangular. Okay? Yep. So on my number 1, I would want you to say by sides is letter A, by angles is letter B. What are we thinking? Is it isosceles, scalene, or equilateral?
Scalene.
I agree. I think it is scalene. What are we thinking about angles? What do we think it is?
It's a fat one.
I think it's an obtuse one by this angle up above at the very top here. I think it's an obtuse angle. I think it is greater than 90. Okay, let's look at the second one here. Who can help me out with number 2? Raise your hand and help me out with number 2. Okay, Jacob.
Equilateral.
Okay, I do agree that it's equilateral.
I don't know if you have two little angles.
And it is equiangular, okay? Real quick, guys, anytime you guys have an equilateral triangle, okay, it's automatically going to be equal angular, and vice versa.
Or could you put acute?
Acute.
We didn't know it was equal angular yet, so if you put acute, let's go ahead and just change to equal angular now that we know. Okay? Okay. Dominic, are you want to help with number 3?
Like in the thing that says we can classify things by their sides, why does the equilateral triangle have 2 legs on each side, but this one doesn't?
I mean, you could really mark it by 2 or by 1. So just and you can mark it really by any number of tick marks. If you want to be obnoxious, put like 30 on there, you could, as long as they each have 30.
Hey.
So we're more concerned about they each have the same amount, regardless of how many of those are.
I'll put 30.
I don't think that really works very well. Let's look at number 3. What are we thinking for number 3?
Scalene.
Okay, I think it's scalene as well,
And that's it, right?
and I think it is a right triangle because of that right angle there.
All of
Okay.
What?
What are we thinking on number 4?
isosceles.
Okay, I think it's isosceles. Kelly, you want to answer the second part? I think it is acute as well, okay? We don't have enough information to say it's equal angular here like we did on number 2. Equilateral triangles are automatically equal angular, but isosceles triangles are not automatically equal angular.
Acute E.
Equilateral.
Never mind.
Correct, and vice versa. Okay. Questions on this at all? Let's continue on. So, sketch an example of the type of triangle described. Mark the triangle to indicate whatever information is known. If the triangle cannot be drawn, write not possible. So I want you guys to try and draw an example of each of these 4. So number 1, I want you guys to draw a triangle that is both isosceles and a right triangle. Okay? So I want 2 of the sides congruent, and I want there to be a right angle.
Not possible.
Yeah.
Yes, it is. It's our line number.
One of these 4 is not possible. The other 3 are possible.
Give me the first one.
One of these is not like the other.
Okay, I think Liam has a pretty decent example this time.
Oh.
Yeah.
Pretty surprising.
Was he confident?
No, I was determined.
So he had a right angle here, and he had these 2 legs being congruent. So in an isosceles triangle, and that's a right triangle, the 2 legs would have to be the ones congruent. You cannot have the hypotenuse be congruent, because do you guys happen to know a little math fact that the hypotenuse is the longest side of a right triangle?
Yes.
It's
Okay.
A squared plus B squared equals C squared.
Yeah, that is where a squared plus b squared equals c squared does come into play, and we'll learn that one later officially. Okay, hi Lainey, bye Lainey. Okay, let's look at number 2 here, and obtuse scalene. Okay, I'm going to draw one similar to what Kaya has here. Okay, obtuse scalene. So all 3 are different measures. You might need to make that more scalene, or more obtuse. Excuse me. There we go. Okay, now it is truly obtuse angle at the top there, and it is scalene since they're all different sides. Okay, questions on that? Okay, Jacob.
Looks like a right angle.
Looks like a right angle. At super is not a right angle. Right angle would be probably around,
I like putting it.
here.
Are you just
Okay.
It's a right angle.
All right, we're going to agree to disagree. It's not marked, and I'm going to say it's obtuse, so now it's obtuse. Here's how we can double check. This is now, just to get under your skin, Jacob, 91 degrees. Okay. Number 3. Dominic, do you have an example of this I could draw?
No.
Why not?
It's not.
It's impossible.
It is not possible.
But I did. But it is possible. It's not right, not possible.
Ah. So if it's a right triangle, then one of the sides has to be longer than the others because it's hypotenuse. But if it's equilateral, all 3 have to be the same length, and it has to be equal angular. So you can't have it be equal angular and right, and you can't have it right and yet equilateral. Okay, Aiden. What?
Are there going proofs for this?
Oh, we'll see. Okay, we love proofs. Okay.
Okay, should it be a right equilateral if it's a square?
That's not a thing.
Wait,
Okay.
proofs on here.
See. Awesome. I'll use Anna's example for number 4.
I know it's like the best thing ever.
And Anna did a good job of making sure to mark that these 2 legs of this isosceles triangle are congruent. Otherwise, you don't know they're congruent. So all 3 angles are acute, and 2 of the sides are the same length, making this an isosceles triangle. Any questions on this one?
I'm putting 30 of these things just to
It
But-
looks like a little plate. Sorry, let me draw this first.
It looks like a little weight, sorry.
Looks like a that person.
Okay. Dominic. Yes, good luck. That's kind of neat. All right. Triangle sum theorem. The sum of the measures of the interior angles of a triangle is
180.
180. If you add up some measure of interior angles of a triangle, you get 180. Meaning in this triangle right here, if we add up the measure of angle A plus the measure of angle B plus the measure of angle C, we get 180 degrees. Now you might notice, once on these shapes, why are we only using one letter for this angle? Well, if you recall back in chapter 1, we can. And then also in and in this chapter now, we're saying, do we need to use all 3 points of the angle to know which angle A is? No, there's only one angle A here, so we can just say angle A. Oh, that's why I have that.
Yeah, so you just want to 30.
Yeah. So, on the right side here, for number 1, if we know the measure of angle A is 42 degrees, the measure of angle B is 52 degrees, what would the measure of angle C be?
Something
86.
Okay, it would be 86 degrees. Gage, how did you get there?
Well, because I took 42 plus 52,
Yep.
which is 94.
Yep.
And then I took 180 divided by, minus 94.
Very good. Take 180 minus the other two angles, which added up to be 94, and you get an 86. What type of triangle would this be then, based upon the angles?
Cute.
It would be acute. It'd be a good-looking one.
Get it? Huh.
I see a theorem. How did I miss that?
Right there. Corollary to that.
All right, let's look at number 2 here. You can have it if you want. What do we think the third angle is on number 2?
90.
90 degrees. Aiden, how'd you get that?
Nah.
Okay, so you take 180, subtract the 45 and the 45, which adds 90, and 180 minus 90 is 90. What type of triangle is this?
Right.
It's a right triangle.
Yeah, I forgot.
What about a left triangle?
Nope. And it's not a middle triangle either.
Have you ever noticed? In the you know the BMW logo, right?
Trying.
Yes.
Yeah. So it says BMW. The B is over the blue. The M is in the middle, and then the W is over the white.
Okay. Wait.
It's cool. Look it up. Because like it says B, and like there's the 4 like square thingies in the middle. It's like a.
Yes.
Look, it's cool.
Okay. I'll look it up again.
BMW.
I've not been impressed in my previous times of just staring at BMW labels, but I will try.
It's impressive.
I'll try again for you, Gage.
Okay.
Okay? Yes, there is another thing here. It's called a corollary.
Oh, coronary.
Nope.
Very.
Corollary to a theorem.
Coronary.
Have you guys ever heard of things being correlated?
Yeah.
Sure.
What's it mean when things are correlated?
They work together.
They kind of work together, they kind of go together, they kind of follow one another, that kind of thing, right? Okay? Corollary to a theorem is going to be very similar. It's a statement that may be proved easily using a theorem. So it's like one step away from the theorem. So a statement that follows a theorem. So we have a corollary to the triangle sum theorem. So the acute angles of a right triangle. So if you have a right triangle, the two acute angles of a right triangle are complementary. What does complementary mean? They add up to 90 degrees. Complementary angles are angles that are nice to each other if we look over at the poster on my wall right behind Aiden and right in front of Dominic. Now, if we think about this, if one of the angles in a right triangle has to be 90 because it's a right triangle, then the other two have to add up to 90, right?
Yeah.
Because they all add up to 180. So then if they add up to 90,
You're right.
they're complementary. Which is why it's a corollary, because it's like, oh, like once we think about it, like, yeah, that makes sense. It's decently straightforward after that. Okay? Yes.
So that means a right triangle is always 45 degrees, 45 degrees.
Great question. Does that mean a right triangle is always 45 degrees, 90 degrees?
No.
No, okay, it could be 50 degrees, 40 degrees, and 90 degrees.
Oh.
The other two just have to add up to 90.
Mm-hmm.
Now, if the other two angles are congruent, then it has to be 45 and 45, right? All right, let's continue on right below this. So we have this triangle here, and I want us to solve for x and find each of the angle measures to classify the triangle. So I know that this angle at the top is x degrees. I know this angle at the bottom left is x plus 20 degrees. I know the angle at the bottom right is 2x minus 40 degrees. Does anyone happen to have an idea of what I could do to help find these angles? Okay, Kelly, go ahead.
Add them all together equals 80.
Very good. We'll add them all together, and equal them to 180 because all the three angles of a triangle add up to 180 degrees. So if we add up all three of these angles of the triangle, we should get 180 degrees. Any questions on that setup? Okay, so now we would solve for x by combining like terms. What's x plus 2x? 4x. What's 20 plus negative 40 or 20 minus 40? Negative 20. So now we add 20. 4x equals 200. Divided by 4, and what's x?
50.
Now we are told to not only find x, but also find each of the angle measures in order to classify the triangle. So what's the top angle? 50, okay. What's the bottom left angle? 70. 50 plus 70. What's the bottom right angle then?
60.
60.
It's 2x.
Okay.
I did want it.
And if we add up 50 plus 70 plus 60, what should we get? 180 to double check our work. And so what kind of triangle is this? Acute.
Pretty one.
Yeah, it's a good looking one.
50, 60, 70, it counts up.
Okay, that's your coffee.
Yes.
I have it.
Okay.
It's so cool.
Let's go to the next page. We're cruising and not even for a bruising. All right. So we have these things called interior angles and exterior angles, right? We talked about those last chapter quite a bit. So interior angles, my goodness.
Int. Let me just put int.
Sure.
With
Int
the dots.
or interior angles, even with the dots, so we know it's abbreviated, are angles inside a triangle. So if we look here, we have this triangle with kind of the lines extended, right?
No.
And you kind of see these reddish hues on the screen.
I do.
Okay, and these, not on the screen, okay, unless you're colorblind, and these three are interior angles, okay? Now, these interior angles, we just said they add up to what?
180.
180, right? Now, the other type of angles we'll have are exterior. Sometimes I joke and I call them outerior.
You wish.
That is
Okay.
so funny.
Exterior angles are angles that form linear pairs with the interior angles when we extend them out. So if we extend these sides out, okay, and I have an interior angle right here, and let's say this interior angle, for grins and giggles, let's say it's, 80 degrees. What would the exterior angle be then if that interior angle is 80 degrees?
100.
100 degrees, right? Okay, let's say this other angle down in the bottom right is, 50 degrees. What's the exterior angle that makes a linear pair with it?
130.
130. Okay, and let's say my bottom left angle, if it's 80 and 50, my other angle has to be 50 as well.
It does.
To add up to 180. And so what would the angle that makes a linear pair with that be?
130.
130.
Yo.
So if we take all three of these exterior angles, what do they add up to?
103.60.
They add to 360 degrees.
Yo. Well, that
What did we? 100, 360.
No, they add up to
But
360.
there's more than just
He said 100 and then misspoke and then said 360. Levi was just saying 360 to start with.
There's more than
Oh, I
just
said it
those
went up.
3 exterior angles.
Yes. So if we add the three exterior angles on, all on the...
To the right.
So if we had one exterior angle for each interior angle.
Okay.
So we're not doing two exterior angles from the same interior angle, if that makes sense. So if we're adding each exterior angle or each different exterior angle from each interior angle, so to speak, then they'll add up to 360. And actually, fun fact, that's the case all the time. Okay, we could have picked any three interior angles, and all the exterior angles will always add up to 360. It's kind of neat.
So,
Doesn't matter until the
is this
Yeah.
one an exterior angle, like this little acute one?
Great question. So Liam just asked, hey, Mr. Kossel, I hear you're pretty great. Is this angle right here that I'm circling and putting an arrow to, is that an exterior angle? Well, let's look at our definition of exterior angle. It's an angle that forms a linear pair with the interior angle. Does this angle form a linear pair?
No.
No, it doesn't. So it won't be considered
Vertical
one.
angle.
It's a vertical angle, so it would also be 50 degrees. Okay? So now each interior angle has really two exterior angles, right? Because I could say this angle over here could be 130 degrees that I'll point an orange arrow to. Once again, when we're adding them up to 360, we're just going to add up one exterior angle for each interior, one at each point. Okay? We're going to use that fact a decent amount, okay? Heads up. Wink, wink, nudge, nudge. We have this exterior angle theorem. Theorems. Okay, exterior angle theorem. The measure of an exterior angle of a triangle is equal to the sum of the measure of the two remote interior angles. It says angles below it, yes. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. What does remote interior angles mean? Okay, well, let's look over here to the right. Remote interior angle is an angle not adjacent or not touching the exterior angle. Let's think about remote. Where do you guys see remote at sometimes?
On the top.
Remote control.
Okay, the remote control. Now, when you're controlling the remote, isn't the whole point of it that you don't have to be right next to the TV or the device you're controlling? That's literally the entire point of a remote control, is you can control it remotely, which means away, okay? Or have you guys heard of remote learning in this time, in 2020, okay? Remote learning means you're learning away from the building, away from the place, okay? So remote means you're away. So remote interior means it's an angle away from it. So if we have this exterior angle down here at the bottom right, the remote interior are the two not touching it. Now, regardless of what angle this exterior angle is, let's say measure of angle 1 in this diagram on the bottom left here is 145 degrees.
Yay.
Well, that now means that the interior angle that it is touching has to be 35 degrees because they're supplementary. And that means if that angle is 35 degrees, the other two angles in the triangle have to add up to whatever will get the 3 to 180, right?
Sure.
Okay, so all three angles inside the triangle have to add up to 180, right?
Yes.
So, if I take 180 minus the 35 for the one we know, these two have to add up to 145.
Yeah.
And that's always going to be the same as that exterior angle.
Oh.
The reason why it's always going to be the same is because in order to find this interior angle right here in the red, we have to take 180 minus the exterior. Well, in order to find the sum of these two angles, we take 180 minus the interior. So you're just undoing what you did. You're finding how far is this from 180? Oh, how far is that from 180? It's just going to be the other number. Does that make any sense or no?
Sure. But not really. How do we know which one is which number?
What do you mean?
Like, how do we know?
Like which ones are the remote interiors?
No, how do you know which one's A and which one's B? Like, how do we know? Like,
How
the
do,
degrees?
so they've added to 145, but they added to 145. So what are each of them, right? So we would have to know information to know each of them individually. Great question. Yeah, so from this information, we could not know what angle A is. We could not know what angle B is, but we know what they add up to. Great question. So measure of angle 1 in this diagram is equal to the measure of angle A plus the measure of angle B, really in either order, because you can add in either order. Great question. The very least above average. Okay? Anybody? Okay. Any questions on this that have not been asked? We're going to put it into practice a bit here. That might help.
I can't read those letters.
A and B?
No, down here.
Oh. Okay, yes. They're pretty blurry. Okay, does this help?
No.
Okay, we're finding the measure of angle B. Let me rewrite these.
Is that a
This right here, 2x degrees.
That's an X?
No, 2z, excuse me.
Wait.
That's a Z?
That's not a Z. That's
That's
an F.
an F.
Nope, it's a z.
Is it F?
It's an F.
That's
Oh, I
two.
This right here is 5z minus 2 degrees. And this right here is 145 degrees.
Where does it go?
If you can't really tell what the variable is, you just use F.
Yeah, if you don't know what the variable is, you can always just use x, or you can ask me, either one. Yep, but if you're away on a homework, you can just plug in any variable. And the only thing that you might have to change later is, instead of x, I'm going to write a z, but I'm really not going to care. Unless we have like multiple variables in the same problem.
Yeah.
Then it's different. So,
I think I have to put a line through my Z's because I wrote my 2s.
yes. That's part of the reason why I write my 2's the way I do, is to make sure they're different than z's.
See, that's why I write my H2 circles, because they get confused.
With what?
I think with everything.
Okay. Yes, Bill.
Why can't you put X instead of Z?
You totally could. You could put a smiley face inside of it too.
Really?
Wait.
Yeah, sure.
Oh, yes.
Start doing that.
Yeah, a variable could be literally any symbol.
Don't say
Oh, I
any.
got it wrong.
No, I mean it could be.
Well,
Can,
don't say
can the
TBD.
variable?
Yeah, I mean you gotta be careful. Let's keep it school appropriate, I suppose. Okay. Yes.
Can the variable be variable?
I said you people, not me.
I mean, it is by definition. Yeah.
Bill.
Anyway. Anyone have an equation we could use to set up to help solve for the measuring angle B on this? Okay, Kelly.
Angle A plus angle B equals 145.
Okay, so let's do 2z plus 5z minus 2 equals 145. Very good. That's using this exterior angles theorem that we just learned. Saying the two remote interior angles, the two interior angles not touching the exterior angle, have to add up to B, the exterior angle. So angles A and B are not touching angles, the exterior angle here, angle DCA. It's meaning they have to add up to equal that. Okay. Questions on that equation and how we set it up? Okay, from here I trust our algebra skills to get 7z minus 2 equals 145. 7z equals 147. Z is what? 21. Now, are we done yet? No, what do we have to do?
Find the measure of angle B.
Plug it in for measure of angle B. Okay, could you plug it into A and B just to double check our work? Totally, you don't have to, but you could. Okay, let's plug into angle B for our answer though. So we have to do 5 times 21, which is 105 minus 2. So the measure of angle B is 103 degrees.
It is.
Meaning you add up to 145, measure angle A should be 42 degrees, which it is. Questions on that? I'm sorry, I thought Aiden was over here. Okay. Okay.
I'm confused on this one.
Okay. On this next one, let's clear up what they are. Okay. So this top right one, okay, this angle here is x plus 2 degrees. This angle over here is 3x minus 8 degrees. Now some of us might think we don't have enough information here. And some of us might be wrong. Because this up here at angle Q is a right angle. So what's the measure of a right angle? 90 degrees. So can someone help me with an equation here that we could use to solve for the measure angle PRS, the exterior angle, okay? Let's go with Aiden.
92 plus x equals 3x.
Okay, so you just jumped the gun and said 90 plus 2 is 92, but 90 plus 2 or 92x, or 92 plus x equals 3x minus 8. We're going to add up those two remote interior angles, the two interior angles not touching the exterior, to equal the exterior. Question on that setup.
I don't get it.
Okay, we have to add, so Jacob, what part of it don't you get?
Most of it. I was supposed to equal 90.
So 90 is an interior angle.
Yes.
If we were looking at, let's say, maybe these two angles that I just circled in pink, then they would equal 90 because they're the other two angles in the triangle that add up to 180. But we're not talking about those two. Does that make any more sense? Okay. So let's do our solving equation. We should get 2x equals 100. Do you guys agree with that?
Yes. Yes.
X equals 50.
Yes.
Okay, x is 50 or 50 is x.
How does 2x do? Oh, I see it. I see it.
Okay, 90 plus 2 is 92. Add the 8 to both sides, you get 100. Subtract the x from both sides, you get 2x.
I had to
Silly
flip it.
You had to flip it?
You can't do it like that.
Yeah, do it like this.
Uh-huh.
So now we plug in that into where?
There.
The x.
Which x? PRS, 3x minus 8, because that's the angle we're trying to find. So we have to do 3x minus 8, 3 times 50 minus 8. The measure of angle PRS is what, Ireland?
142.
Nailed it, 142 degrees.
Nailed it.
Nailed it. Questions on that?
No.
All right, does anyone still need this? Continuing on then. Let's look at this last problem for the section. If the exterior angle drawn measures 150 degrees, hence 150 degrees there, and measure of angle D is twice that of measuring angle E, find the two remote interior angles. Think about it, don't blurt. Think about it, don't blurt.
Do we do it?
You can if you want, but think about it, don't blurt. Think about how you'd solve this one.
I don't know.
Oh.
I wasn't here during the
Okay, so equals
I see.
50.
I'm so tired.
Hi, so tired of Mr. Carlson. Nice to meet you.
The cheering pie staying up late is getting to me now.
Yeah, Sarah, are you taking your test tomorrow or Thursday?
Probably tomorrow.
Okay, cool. When are you coming in?
I realized so tomorrow is not math.
You're right.
You just realized that?
Yeah.
Nice.
Okay. Anyone able to help me on this one?
Max is.
Sierra, can you help me on this one? No? Okay. Gage?
Yeah.
You can help me?
I can. help
Okay,
you.
go ahead and help me, Gage.
Well, it says 180, so that means D and E have to add up to 180.
You mean
I
150?
mean 150, sorry.
Okay.
D and E have to add
So we
up
know that measure of angle D and measure of angle E have to add up to 180. We know that.
and I know 100 plus 50 equals 150. And
Yo.
50 is half of 100.
Okay, so you just kind of guessed and checked.
Sure.
So you said, oh, okay, well, if I guess and check here, I can get 50 plus 100, okay? Does anyone know the algebraic way we could go about this? Okay, Max.
I don't know that.
You can divide
I'd like to
150
know.
by 3.
Okay?
Well, you know that D plus E equals 150, and then you can divide 150 by 3.
Okay, so you know you basically have 3 equal parts, and D just has 2 of those equal parts because it's twice that.
Right.
Another way to verbalize that algebraically is if we call E x degrees, what would we call D?
Z degrees.
2x degrees, double it. So you can say mathematically 2x plus x will equal 150, which is essentially what these two boys both did, okay, Gage and Max, and saying 3x equals 150 divided by 3, x is 50, so measure of angle E is 50 degrees, measure of angle D is double that, 100 degrees.
That's big.
The algebraic way to set you up for success in other problems is calling one x and one calling one 2x, or one a variable and one double that variable. If you wanted to, you could call measure of angle dx, measure of angle E 1/2 x, but then you're creating fractions for no reason.
Okay.
Yes, that'd be quite an odd demonstration of wealth and power, but I suppose. Okay, does anyone have any questions on this?
I do not.
No!
Don't do numbers. 9, 12, 14, 21, 23, 24, haha, 26, 28, and 31. If you missed those, they are on the bottom left of the board.
28, 31 is a
Highest number.
9. I wish I could do that one though.